All right, question number 9 says H, J, K, and L and M are points on the circumference of a circle with center O. M, K is a diameter of the circle and it is parallel to HJ. M, J, and JL are MJ is equal to JL, and the angle JMK is equal to 38 degrees. So all that we just said is what we can see for ourselves. We're to explain, given a reason, why angle HJM is 38 degrees. So let's identify angle JM. Angle HJM is this angle here. It's angle HJM. All right. So it's that angle there, the angle at J. So this is the angle here. All right. So I hope everybody can see the parallel lines. And if you can see the parallel lines, then you can see that angle HJM is equal to angle JMK because the two angles are what? Alternate angles. So I would say that angle HJM and angle JMK are alternate, JMK is equal to 38 degrees, which is equal to 38 degrees, are alternate angles. And alternate angles are equal. All right, so that angle is equal to 38 degrees because the two angles are alternate angles and alternate angles are equal. All right, so the next angle is we need to explain why MJK is 90 degrees. MJK is this angle here, and we're told that it's 90 degrees. All right, so first of all, MK is a diameter, and the diameter divides the circle into what? Into semicircles. So angle MJK is equal to 90 degrees because it's an angle in a semicircle. So angle MJK is equal to 90 degrees because it is an angle in a semicircle. All right, so let me just go back up and show you that. So MK here is the MK there is the diameter, and MJK that's the angle that's equal to 90 degrees, and it's called an angle in a semicircle, and the angle in a semicircle measures 90 degrees. How do you identify it? You start at one end of the diameter, go up to the circumference, come down at the other end of the diameter, and the angle that is formed at the circumference is equal to 90 degrees, and it's called an angle in a semicircle. All right, what next? Next, we are asked to determine the value of each of the following angles. Show detailed working where appropriate. So we need angle MLJ. Angle LJ, angle MLJ. We need this angle here. To identify it, we need that angle, theta. It's angle MLJ. All right, let's see how we're going to find it now. All right, so to find MLJ, which is theta, I'm going to first find this angle here. Let's call it alpha. All right, and I'll explain why afterwards. So if I'm looking at this triangle here, let me just try and identify this triangle. All right, that's my right angle triangle. So looking at the right angle triangle, all right, so the angles in a triangle measure what? 180 degrees. The angle at J is 90. So I can find the angle at K. Which is alpha. I'm going to say alpha is equal to 180 minus 90 plus 38. It's 180 minus 128. This is 52 degrees. Now, so that angle is 52 degrees, but that's not the angle I want. Now, angle MLJ is equal to this angle alpha is equal to what? 52 degrees. The two angles are equal because they are angles in the same segment. All right, so these two angles are equal because they're angles in the same segment. So let me show you what I mean. Going back to the diagram, let's change the color because now these two angles here, the angle at L. All right, it's not helping me at all. Let's go again and see what happens. And see if we, all right, nothing. All right, let's go triangle instead. That should work. All right. So, all right, that angle there and this angle here. All right, these two angles all right, these two angles are angles in the same segment. Let's show you how you identify it. Both have the same starting point and the same ending point on a chord. The chord is MJ. So one starts at M, go down to L, and then back to J. The other starts at M, go down to K, and back to what? J. This angle here is, what was it? The angle here was 52 degrees. So if this angle is 52, this angle which I'm searching for is also 52. And the two angles are called angles in the same segment. All right, let's move on. Next, we need angle what? L, JK. Angle L, JK, angle L, JK. That's this angle here. Angle L, JK. All right. To find that, I'm going to find this angle. Because this angle and this angle here, let's call this beta and gamma. Both of them are what? They're angles, also angles in the same what? Segment. If you look carefully, you'll see that MJL is an isosceles triangle. So if the angle at L is 52 degrees, the angle at M is also 52 degrees. So that being said, it means that what gamma is equal to 52 minus 38. And I think that this is 14 degrees. So this angle here is 14 degrees. And this angle here is also 14 degrees for the same reason as the question before. They are both angles in the same segment. How do we identify it? Start at L, up to M, up to the circumference at M, come back down to K. The second one, start at L, up to the circumference at J, then come back toward K. Those two angles are equal. They're called angles in the same segment. So I would say that angle what? Angle JHM is equal to angle all right, it's JHM I was finding. No. Oh, I already said it's equal to angles in the same segment. LJK. So angle, this way I should write it, angle LJK is equal to angle LMK, angle LMK is equal to 14 degrees. They are angles in the same segment. All right, last part of this question, angle JHM. Now, JHM is this angle here. Now, I'm going to show you how we're going to conquer that one now. All right, I'm going to show you this shape. I'm making it blue again. Not helping me. Go again. Not helping me. Shape the, I think not helping me. But anyway, MHJL is a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral are supplementary. So these two angles here must add up to 180 degrees. They're opposite angles in a cyclic quadrilateral. So MHJ, angle MHJ is equal to 180 minus, I think it's 52. Let's double check. It's 180 minus 52, which is equal to 128 degrees. They're angles, sorry, they're opposite angles of a cyclic quadrilateral. They're opposite angles of a cyclic quadrilateral. All right. All right, let's move on to the last part of this question. It says, from a port L, ships R is 250 kilometers. From a port L, the ship R is 250 meters on a bearing of 65 degrees. And the shape T is 180 kilometers from L on a bearing of 148 degrees. All right. This information is illustrated in the diagram below. We're to complete the diagram by inserting the value of angle RLT. So we need angle RLT. We need that angle RLT. Here's what we know. The angle from north coming around to LR is 65. The angle from north coming around to LT is 148. The angle between them would be, so angle RLT would be 148 minus 65. That angle is 83 degrees. 83 degrees. So let's make it red. The angle here is 83 degrees. It's 148 minus 65. We're to complete the diagram by putting in that angle, which we did. We're to calculate the distance between the two ships. The distance between the two ships is RT. That's the distance between them. Now, RLT is a non-right angle triangle, of which I know the lengths of two sides and the angle between them, which is the inclusive angle. And I wish to find the length of the third side. To do that, I'm going to use the cosine rule. The cosine rule says C square is equal to A square plus B square minus 2AB cosine big C. Using this formula, this would be my A, this would be my B, this would be my big C, and this would be my little c. So putting in everybody, we have little c, which is x square is equal to 180 square plus 250 square minus 2 times 180 times 250 times the cosine of the angle between them, which is 83 degrees. If I put everything here in my calculator and press equal, I'm going to end up with 83,931.75909. The opposite of square is square root. So x, which is RT, is the square root of 83,931.75909, which is 289.7 kilometers. Lastly, we're asked to determine the bearing of T from R. So we need the bearing of T from R. Now, let's put in the angle that represents the bearing of T from R. So wherever I'm going to take my bearing from, I'm going to put my north, south, east, west lines. Bearing is measured clockwise from north. So I need this angle here. All right. So let us see how we're going to get that angle. Now, The best way I think I'm going to get that angle. I'm going to first find this angle here, the blue angle, which I'm going to divide into two parts. Let's call it alpha and theta. Alpha and 65 are co-interior angles. So I can say alpha is equal to 180 minus 65 which is what? 115 degrees. They are co-interior angles. And let's find theta. To find theta, we're going to have to use the sine rule. So we're going to have the sine of theta over the side opposite from theta, which is 180, is equal to the sine of 83 over the side opposite to the 83, which is the 289.7. Do my half cross multiply, I get sine theta is equal to 180 sine 83 over 289.7. Work that out, I get sine theta to 3 decimal places is 0.617. If I know the sine of an angle and I want to find the angle, I'm going to use sine inverse. So it's sine inverse 0.617. This is equal to 38 degrees. So the bearing of T from R would be equal to 360, the red angle, minus the combined blue angle, which is 115 plus 38. This bearing is 360 minus 153. The bearing is 207 degrees. The bearing of T from R is 207 degrees.